Okay, this video is about graphing absolute values. So it teaches you something that we haven't done before, but it also reviews a lot of things that will be on your final exam because it reviews a lot of concepts that we've done this semester. So first of all, let's talk about the parent function, f of x equals the absolute value of x. So if you remember, we didn't make a lot of tables, but when we did, the points you plug in would be -2, -1, 0, 1, and 2. And we've absolutely done this before. This is not brand new, but when we take the absolute value of a number, it's always positive. So this is +2, 1, 0, 1, and 2. Doesn't matter what it starts with, it's always positive because remember, absolute value measures the distance from 0, and distance cannot be negative. All right, so if I graph those points, I have 0, 0, 1, 1, 2, whoops. I should have put my glasses on to make the video. 2, 2, then -1, 1, -2, 2. Now, I'm not asking you to plot more than this, but I want you to see this because it's going to help us in a little bit. This is just a pattern, right? It's just going to go up and it's going to make a perfect V. And you can just make these points. We don't really need to know all of them. They're all going to make this pattern. Okay, so this is the parent function for an absolute value. And now we're going to take that parent function and transform it or shift it different directions and see what happens. So if we add a to the function or add a number to the outside of the function, it shifts the graph up. And if we subtract a number, it moves it down. But remember, when it's inside of the function, it's the opposite of what we naturally think. So adding a actually is to the left and subtracting a is to the right. If we multiply the function by a number and that number is greater than 1, then it is a vertical stretch. And yes, you do need to have vertical in front of it because like we talked about, this year we're focusing on vertical stretches, but horizontal stretches do exist. And so there's a difference. Okay, if you multiply the function by a number, but that number is between 0 and 1, remember we think fractions, then it is a vertical shrink. And last but not least, if you put a negative in front of the function, it is a reflection and it flips the graph over. All right, so let's take a look at these. We're going to state what the transformations are, and then we are going to graph it. Okay, so on this one, it's going to be the -3 inside is the opposite what it's saying. We think, so it's going to be right 3, and the +5 is going to be up 5. Now, normally on a parent function, the vertex is at 0, 0, but now the vertex or the starting point gets moved over right 3. Oh gosh, I gotta blow this up. Okay, and up 1, 2, 3, 4, 5. Once you have the starting point, we know that the absolute value just goes over 1, up 1, and forms line in either directions. Okay, let's take a look at number 2. On number 2, because the +4 is inside, it's the opposite. So that means it's going to go left 4, and then the -6 is going to be down 6. So normally the vertex is at 0, 0, but this time it's going to be left 4, 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. And then once you know that, you can just plot the points of your V. And if you needed more points, you could easily do so. All right, let's see what happens here. So here, the negative gives us a reflection. The +6 is inside, so it's the opposite. So it is left 6, and the +8 is outside, so it's going to be up 8. So I'm going to go left 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, 5, 6, 7, 8. But this time, instead of making my V open up, this time my V needs to open down because it's a reflection. Okay, let's look at number 4. The 3, because it's greater than 1, is a vertical stretch. The -3 inside is the opposite of the direction we think. So it's going to be right 3. And then the -9 is going to be down 9. Okay, so I'm going to go over 3 and then 1, 2, 4, 5, 6, 7, 8, 9. Okay, and now normally we go over 1 and up 1, right? And we just keep repeating this pattern. Remember, the over doesn't change, it's how much we go up. So we're going to go over 1 and up 1, 2, 3. Now I could go over 2 and up 6, or I could just repeat that pattern from this point. Over 1 and then up 1, 2, 3. Over 1 and up 1, 2, 3. And I remember this is my vertex, so I have to go the other side. Over 1 and up 3. And then here is my absolute value. Okay, sorry about that. All right, let's take a look at this one. So on this one, the 1/2 is a vertical shrink. There's nothing inside of the absolute value, so it's not going to go left or right any, but it's going to be down 7. So I'm going to go down 1, 2, 3, 4, 5, 6, 7. And then normally we go over 1 and up 1 and keep following that pattern. But this time we're going to go over 1, but only up 1/2. Over 1, up 1/2. Over 1, up 1/2. Now I have to go the other way. Over 1, up 1/2. 1 up 1/2. 1 up 1/2. And now it's wider. Okay, let's see what happens on number 6. Number 6, we have lots of transformations. So the negative is a reflection. The 2 is a vertical stretch. The 4, because it's inside, it's the opposite of what you think. So it's going to be left 4. And the +6 is going to be up 6. So we're going to go left 1, 2, 3, 4. And up 1, 2, 3, 4, 5, 6. So that's where we're going to start. And this time it's going to be opening down. So if it was just a 2, but it was opening up, we'd go over 1 and up 2. So now we have to go over 1 and down 2, over 1 and down 2, over 1 and down 2. And now we got to do the same thing, but going the other way. Oh, well, that's perfect. We made a Christmas tree and it's green. We can make it more fun. Okay, now one more problem that we got to look at. So this one, we're still going to graph it like before, but we're going to review our key features of the graph, because key features of the graph have come up a little bit in each chapter. We keep talking about them, but they're also going to be on your final exam. So this is a really good, and it's the way we started the chapter. So it's a really good way to bring it all together. So for this one, we're going to go right 3 and then up 5. Okay, so right 1, 2, 3. 1, 2, 3, 4, 5 is right here. And it doesn't have a stretch or reflection, so we can just make our points. And there is our graph. Okay, so let's go through and answer the questions and kind of see what we remember. So domain is left to right, and it's the x values. Oops. I can spell that correctly. So as we go left to right, it just keeps getting wider and wider. So that means as we go left to right, everything is going to be included. So we say it's from negative infinity to infinity. The range, however, goes from bottom to top, and it's the y values. So I'm not reading it off of the x anymore. I'm reading it off the y. So down here, I've got nothing. And I've got nothing all the way till I get to here on the y. And that is at 5 on the y. And that point is a closed circle, so it's a bracket, and then it doesn't stop going up, so it goes to infinity. Okay, the next one's the x-intercepts. The x-intercepts, remember, are some number, comma, 0. And it's where it crosses the x-axis. So here's the x-axis. And if I look, this graph is never going to cross the x-axis. So in this case, it has none. Sometimes it'll have 1, sometimes it'll have 2, and sometimes it'll have none. And any answer is okay. All right, the y-intercept, those are always zero-sum number, and it's where it crosses the y-axis. Well, where it crosses the y-axis is right here. So we're going to have to count that off the graph. 1, 2, 3, 4, 5, 6, 7. So it's going to be 0, 7. I'm going to erase some of this stuff so we don't get it confused. Okay, positive intervals. Positive interval, we read off of the x-axis, okay, and it's above the x-axis. So we're going to look at this and ask ourselves, where is this graph above the x-axis? And the answer is it's above the x-axis everywhere. It never goes below. So the positive intervals, and from left to right, it never stops. So the positive intervals is from negative infinity to infinity because it's always positive. It doesn't matter where you go on the graph, it's going to be positive. But negative intervals, it's never below the x-axis. So this is going to be none. All right, increasing and decreasing. Remember, this was our roller coaster. And when we ride the roller coaster, we have to ride it from left to right. Okay, this is going up, this is going down, and we read it off of the x-axis. So as I go the far left and I get on my roller coaster, it is going down. So this is decreasing. So it starts decreasing way out here on the left, which is negative infinity, and it stops decreasing right here, and we read it off the x-axis at 3, and we put a parentheses because at 3, it's neither going up or down. And then at 3, it changes directions and it goes up. So from 3 all the way out here to the right to positive infinity, it is increasing. Okay, let's do one more of these. Number 2. So the transformations, this one is a vertical stretch. And the +7 inside tells us that we're going to go left 7. And the -6 tells us that we're going to go down 6. So start at 1, 2, 3, 4, 5, 6, 7. And down 1, 2, 3, 4, 5, 6. Now this time, because it's a vertical stretch, instead of going over 1, up 1 each time, we're going to go over 1, up 2, and over 1, up 2. Okay, over 1, up 2. Okay, so over here, I'm going to go over 1 and up 2. And I'm going to keep following my pattern. Now, I can go ahead and graph these, but I know because I'm going to have to find all of these different things, I need to know where it crosses the X and crosses the Y. Well, I can see where it crosses the X, and I know it's going to cross the Y, just I haven't marked yet. So I'm going to go ahead and keep going till I get to the Y, so I can later on figure out what that exact point is going to be. And now I have that. Okay, domain. Domain is going left to right, and we're reading off the x-axis. Well, left to right, it keeps getting wider and wider. It's everything. So it's going to be negative infinity to infinity. The range goes from the bottom up. There's nothing down here, but it starts here, which is at the 6 on the y. So it starts at 6. That point is included and continues up to infinity. The x-intercepts is where it crosses the x-axis. And it crosses here and it crosses here. So it looks like cross at 1, 2, 3, 4, which would be 4, 0, and at 5, 6, 7, 8, 9, 10, and at 10, 0. The y-intercept is where it crosses the y-axis, which is here at 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to be at 0, 8. Positive interval. Positive interval is everything where it's above the x-axis. So it's above the x-axis here and it's above the x-axis here. So there's two sections. So I'm going to have to write two intervals. So the first one starts way off at the left at negative infinity, and it keeps going to here. That's where it stops being positive. And there we said was at 10. And then it starts being positive again over here, which is at 4, and never stops and goes to infinity. Okay. The negative intervals is the section where it is below the x-axis. And it is below, we got to read it off the x-axis. It starts below. Oh, guys, I made a mistake. This is not positive. This is negative, isn't it? I'm on the left side. I'm so very sorry. Okay, so when I read the negative intervals, it starts being negative on the left at negative 10, and it stops being negative over here at negative 4. Okay, increasing and decreasing. I'm going to read it from left to right. So as I go from left to right, this first section here is going down. So that is decreasing. So it started decreasing at negative infinity and stops right here. Well, that is 1. Well, this is 4, 5, 6, 4, 5, 6, 7. So it's going down from negative infinity to negative 7. And then at negative 7, it changes directions and is going up. So from negative and 7, and it never stops going up. So negative 7 to infinity. And there's your absolute value graphs.